Okay, so now we will talk about the data plots. So, in fact, we are following a path like this. So, at first, we say that, well, we write the data into an Excel sheet, okay, 3, 7, 7, 5, 5, and then 3, 8, 3, like this. And in the second part, we say that, well, it's hard to understand what the data looks like. Okay. So what we do is we just make a frequency table and say that, okay, in for tree, we have, let's say this is Xi and this is Ni. You have four many trees. So you have, for example, too many fives here. You have too many sevens, and you have what? One eight. So this is the frequency table. In the next step we say that, well, that's fine, but we can summarize it in a you can further summarize it. So what we do is we just put this into a group table and we say that, well, how many data do we have between 0 and 3, how many data do we have between 3 and 6, how many data between 6 and 9, and so on and so forth. Okay, so this is one way, remember. And we also talk about, well, how can we further summarize the data? We say that there are three important measures which summarize the data very well. One is the what is the centrality, what is the central measure, okay, of the data, which is the arithmetic mean or the median or mode. There are several measures for centrality. And the other part is the dispersion, okay, or the variance. So how much the data scattered around the center. Okay. Now we will try to see. Okay, how can we further understand or dig the structure beyond the data, the inherent structure in the data. Okay. So, well, there are the temperature data of a drying oven, okay, which is measured at every 15 minutes. Okay, so this is the data that we have. Okay, well, this is the raw data, right? So if you just write this into the Excel, well, you don't understand anything. So what does it look like? What you cannot figure out anything about data, right? So this is in fact a confusing list of numbers. Okay. Um, so what we do is first you can of course make a frequency table. Okay, I skipped that step. You can just do it at home, and then you can just make a what you can make a you can make a grouped data. Okay. So how to group them? How many of them between 30 and 35? How many of them between 35 and 40, 40 and 45, 40 and 50? So although, okay, sorry for this, although we have a frequency here, so this is in fact, the frequency of the group data, right? So this is in fact a group data, right? So there are 11 many items between 40 and 45. You can check it. One item between 30 and 35. Let's see here, 30 and 35, that's 32. Okay, that's here. And three items between 35 and 40. And please note that the lower interval limit is included and the upper limit is excluded. So between 35 and 39. Okay, so let's look at here. Let's this one. Okay. And what else? You have 39 here. I need one more. You have 37. Okay. See, there are three items here. Okay? And this is the frequency table, right? So this is the frequency table of not individual observations, but this is the frequency table of the group data. Okay. You just group the data and find the frequencies of these groups. Okay. And here you have, this is the cumulative count, or let's say this is a sort of less than or equal to, less than or equal to, let's say, column. So you have one item which is less than or equal to 35. Okay. In fact, sorry, this is the group data, but if you say less than or equal to is not true here. So let's say only less than, right? Only one item that is less than 35, four items which is less than 40, right? and 15 items which are less than 45, 33 items which are less than 50, and so on and so forth. So how do you find this, of course? So you have one item between 30 and 35, three items between 35 and 40. So if you just sum them up, 1 plus 3, that's equal to 4. There are 4 items which are less than 40. If you sum these two, then you have 15 items which is less than 45. Okay? And what else? So you have 45 items which are less than 55. Okay? And these are the percents. This is 1 divided by what? You have 55 many items here. So this is 1 divided by 55. That's equal to 1.8%. So that is 1.8% of the data is between 30 and 35. That's what we have. And this is a histogram. Okay, what's a histogram? That's a very simple plot. What you do is you just write the value of this interval. Okay, 30 up to 35, 30 up to 35, and you just write the what? You write the frequency of this interval. So that's equal to what? That's equal to 1. So that's the bar chart. Okay, the bar chart where the bars represents the intervals. Okay. So this is 30 up to 40. You have 3 items there, 11 items, 18 items, 12, 7, and 3 items. Okay. So this is a histogram. And histogram just shows you what does the data look like. Okay. So it turns out that, well, the data is centered around 45 and 50. So the number of data just goes down if you go further from the mean. Okay. So it's probably symmetric. Okay, not very far away from symmetric. Um, and that's what a histogram does for us. So another type of plot is the stem and leaf diagram. Okay, stem and leaf diagram. So what does it look like? Please just look at here. In fact, it looks like a histogram, but it's a horizontal type of histogram, right? How do we make this? Well, just look at here. You have two threes here. So in fact, this one refers to 32, okay? And this one refers to, so what you do is you just write, in fact, 37, 37, and 38. So what you do is you don't write threes here. You just put the threes there, okay? So this is 32, and this is 37, 37, 38. If you just look at here, this is 40, 40, 40, 41, 42, 43, 3, 44, 44, and the remaining ones are just there. Okay? Again, this is the vertical version of a histogram. But the thing is that, well, as you can see, as the number goes up, it's very hard to uh, construct this stem and leaf diagram. So this stem and leaf diagram is only suitable for data sets that are not very, very large. Okay. So another plot is the box plot. Okay. So what's a box plot? Well, it's something like this. Okay. So you have a so this one is the scale of the data, and this one shows what your data looks like. So it shows the median of the data. Okay, at the center, this part. Let me change the color because that's red as well. Right? So this is the median. This is the upper quartile. That's Q3, and that's lower quartile Q1. Right? And this part, sometimes it is denoted as the minimum, okay, minimum data, and this is the maximum data. But sometimes they are different. So, okay, as you see, so this is minimum and this is the maximum of the data, right? This is the median, this is the lower and upper quartile. Um, but sometimes this vertical lines here, or the lines that we have here, okay, this line and this line, they are not minimum and the maximum, but they are Q1, okay, minus 1.5 times the interquartile range. So what is interquartile range? The interquartile range, remember, is the difference between Q3 and Q1. Okay, so you calculate it, right? You calculate this, and you just subtract it from Q1, 1 minus 1.5 times IQR, and that's your limit. Okay, and here what you do is you just put again 1 plus 5 IQR to over Q3, right? And that's your limit. Okay, and that's how you plot box plot. So the data that are outside of this region, okay, these data and these data are called outliers, which means, well, they are not very conforming. They are not conforming to the existing, the remaining existing data. We will deal with the outliers, especially in the linear regression case. Okay. So let's stop here and we will continue in the next video.